Hi there, welcome back to another tutorial video on PCG. It's been some time between episode 3 and 4, sorry about that. But we are back on track with this promised episode when we're going to talk about splines, finally. If you didn't watch the previous videos, no worries, I'm trying to make those videos standalone, so you can come back to it when needed. I'll still start from the end of episode 3 for this episode. Today we are going to see how to handle landscape spline and spline. They are different in Unreal. Landscape spline are created via the landscape tool, and spline are just components added to an actor. We'll see how to create a road with a landscape spline, remove it from the already generated forests, and then we'll see how to deal with close spline to create a clearing in our forest that is adapting automatically if we change the spline. That's basic building blocks that you can combine to do advanced stuff. So let's get started. So first, I'm just going to go back to my previous graph and disable the trees just to have a better view of my map. You can see that I already have some spline defined, but we'll come back to it later. So we go into the landscape mode and we'll use the spline tool. Then we're going to hit control and clicking to create control points. So we'll change the width of the spline. So we're going to select all the control points and change the half width by 200. So we also need to change the side fall-off, so we change it to 200, and same for the end fall-off. It is because we want the edges to match our road. I also want the side to match my width, so I'll set the left-right side fall-off factor to 0. That's what we will use for the spline bound, so it is important to have it right. To have a nice road, I added a spline mesh to it. I have a nice road mesh provided by my colleague Pontus from the Quixel team, so thanks a lot Pontus for this road. So I will select all my segment and I will go to the spline meshes, add one, and then I will take my road and just drag it there. So I have my road there. Now that we have our spline, we can go back to the graph. I will re-enable my trees. And now we want to exclude the spline from the generation. So we go back into our graph and add a getSplineData node. To get our landscape spline, we don't have a lot of options in the basic world. In a world partition map, you can tag the spline and recover it, but in basic world, you don't have access to it. So we're going to add a new getSplineData node, change the actor filter to all world actors, and we will have to go by class and find the landscape, and the node will try to find a spline component on that actor. If we go to debug and inspect the node, we can see that we have points. That is a PCG landscape spline data. You might have a warning. That's a bug on our end. It says that the landscape spline is not a spline, but it will be fixed for the next version. So you can safely ignore it. So now that we have our spline, we need to sample it. So I will just drag it and introduce the new node spline sampler. And I will hit debug. And you can see that we have this big rectangle there. It is because the subdivision is done on the segment and we only have 1 point per segment. So what we're going to do is we're going to change it to distance and then we're going to do 50 increment to have more points on our spline to follow it better. So now we have this very nice spline road through our forest. Now that we have points, we need to exclude the points from the landscape. So we are going to create a difference node. We're going to move all the pins to this one. Of course, change the density function to binary. And then we are going to replug the landscape ID to the source. And then we will exclude the points from the spline sampler. So with that, you can see that we still don't have an exclusion from the road. That's because the landscape height is a continuous spatial data. So we need to change the mode from infer to discrete. And with that, we can see that we have our road that is clearing the trees and the foliage and everything. But there is a problem there. You can see that we'll still have the debug points shown there, but it seems that we are removing a lot more than what we see from the boxes. And that's the joy with PCG, it's full of surprise. Now I'm joking there. The culprit here is the steepness on our points. So if we go to the spline sampler and we inspect it, you can see that the steepness there is 0.5, which is the default value for all new points. The steepness is a bit complicated to grasp, but it means how the density is supposed to fall off on the edges. Here we have a density of 1 on the boxes, you see, it's white, but there is a residual density on the edges defined by the steepness. Because of this residual density, the difference nodes will count it as to be excluded. A value of 0.5 means that we have half the width of our bounds as residual density, with linear falloff. A value of 0 means that we have the total width as residual, and a value of 1 means no residual density. So we'll need to change the steepness from 0.5 to 1. Unfortunately, there is no single node to do it. There will be one in 5.3, but right now we don't have one. And it means that we have to use a temporary attributes to do that. So we'll talk about attributes in future videos because it's a very powerful tool, but I'll stick to the basics there. An attribute is just an extra metadata that is stored on our data. In the case of a point data, we can have extra data for each point and it's referenced by an attribute. So in my case, I want to take the output of the spline sampler and add an attribute to it. So I will do add attribute. And we said that we wanted to change the steepness, so I will name it temp steepness, and I want it to be 1. If I inspect this node, you can see that I have a new column in my data that is temp steepness, and we added an attribute that is 1 for all the points, which is exactly what we want. We want to have 1 everywhere. This is like a temporary value. We need to put it into the steepness, so for that we will add another one that is called attribute operation. Note that this one will be renamed copy attribute in 5.3, but here it's still attribute operation. So we want to take our new attribute, what we call temp steepness, and we wanted to write it into the steepness. So attribute operation works on attributes and properties. Properties will have a little plus on the right. So I want to write onto the steepness, and you can see that properties are prefixed by a $sign. What I'm meaning there is that I want to take temp steepness values and output it into the property steepness. So if I inspect the attribute operation, you can see that now my steepness is 1 everywhere. If I change the value there to 0, the steepness is 0 everywhere now. Right now what we're going to do is just plug it back into a difference, and now we can see that the spline width is respected. If I go back and set it to 0, you can see that the width is way bigger. And if I go back and reset it back to 0.5, which was the value that we had before, the exclusion is narrower. So let's put it back to 1 because it's what we want. For now, we finished our first goal, create a row that will be excluded from our forest generation. For completeness, I'll show quickly that we can do exactly the same thing with splines. I have another spline already prepared. So if I remove the trees there, you can see that I have already a spline there. So I will do exactly the same. I will do get spline data. This time my spline has a tag. So if I go to my actor advanced tags, you can see that I already added a tag that is called PCG spline road. So we will do exactly that. We go to all road actors by tag. And then we can inspect it to see that if we have some points, and we do. If I debug it, you can see that I have already a nice spline with a nice width. That's because it was already prepared. By default, the width is 1, so you will have a very, very small spline. So if I go back to the spline, I want to select all the spline points. You can see that the scale is 200 on the y-axis. Let's set it to 1, which is the default value. That's what you should see. So we'll put 200 because it's the width that we want for the exclusion. So now that we have our spline, we can just take the spline and plug it also into the spline sampler. We can do it because the spline sampler accepts multiple data and multiple inputs as an input. So it means that we will have the 2 splines that will be sampled, and then both of them will have their steepness fixed, and both of them will be added to the difference. So if I go inspect my spline sampler, you can see that I have 2 outputs now. And you can see also that the steepness is respected there too. So I can remove the debug information, and now you can see that I have 2 splines. One is the landscape spline, one is the normal spline, and both of them are excluded from the generation. I can move them, and it will automatically change the generation. So let's switch to the clearing and close spline. I already have a spline that is pre-created, so I will just remove the tree so you can see it. So this spline is marked as closed loop, and it will delimit our clearing. I also added a tag to it, PCG spline, so it will be easier to get it into our graph. So I will go back to my graph. I'll just clean it a bit. So we'll do the same for the closed loop. We're going to get spline data. And for this one, we're going to go to all world actors by tag, and it's PCG spline. And inspect it to see if we have points. We do, so this is cool. You can also debug it. And you will see like small points on it. But here we don't want it to be on the spline, we want to be in the spline. So we're going to add a new spline sampler. This is the same node, but this one will have another mode that is called dimension on interior. And if I debug this, you can see that now I have points that are sampled into our spline. By default, all the points have a density of 1. In our case, we want to do a clearing. Basically, we want to remove points that are inside the spline. But removing the points like this will mark a very rough transition between the forest and the clearing. So we'll try to do something a bit more subtle, where the trees become sparser and sparser and also a bit smaller until we reach the center of the spline. There is a built-in tool in the spline interior mode when you can change the interior density fall-off curve that will define how the point density should be depending on its distance from the spline. So right now it's 1 everywhere. Let's add our first point. So if I go to interior density fall-off curve, I want the center, which is times 0, to be 0. So if I put a point there, you can see that all my points are now turned black because they will all have a value of 0. Then I add another one for 1. So I mean that at the edge of the spline, I want it to be a density of 1. So you can see that it's white on the edges and it's black on the center. We have a density that is getting smaller and smaller until we reach the center. We'll change it to auto there just to have a smoother fall-off. Now that we have a density that changed with the distance to the center of the curve, we'll do some filtering. But first, we need to remove the original generation from the spline. You can see that I still have the foliage there, and if I re-enable the trees, they are still there. So we'll remove them because we will have a special rule for the interior of the spline. So we'll have the same issue with steepness. Since the points have a steepness of 0.5, the junction between the forest and the clearing will be weird. Fortunately, the logic that we did earlier can be reused without any additional cost. Just plug the output of the spline sampler into the stump steepness, and boom, everything is removed and everything is clean on the edges. So you can see that we have a lot of points there. So we'll try to remove some, and we will do a point sampler. And we'll keep only 20% of the points. So if I debug this, you can see that I have a smaller set of points. And from there, we want to remove points that have a low density. But the density filter we used before is linear. It means that we'll still have a clean cut between trees and the clearing. You can try. If I go to density filter, there, we can see that we have like a rough transition. To make it smoother, we'll apply some noise to the density. So for points that have a low density, we still want to give them a chance to make the cut. So we'll add in between a density noise, where we're going to multiply density, and the ratio will be between 1 and 5. So with that, we have a smoother distribution of density around the center. And so now I can apply my density filter. I would put it a very small value. You can play a bit with it, but I already did some tests, so it will be 0.12 for me. It's getting sparser and sparser the closer I get to the center, so it's better like this. What we could do then is to do some random transformation as usual. So I'm going to add a transform point. I guess I will add some offset to the position. I would debug the transform point to see it. So a bit of offset on the position. Also, we want it to be a random rotation around Z. Then we can scale it a bit. And of course, after that, we want to remove any overlapping points. So we'll do a self-pruning node. So we already have some logic in the static mesh spawner to spawn different trees with different probabilities, and we still want to use this one. Fortunately, the static mesh spawner also accepts multiple inputs. So if I want to spawn trees, I will just take the output of my self-pruning node and plug it into the static mesh spawner. And with that, we have our trees spawning into the clearing without any trees in the center, and it's getting sparser and sparser the closer I get to the center. It's not yet very clear that the trees are sparser, so let's add another transformation. We want the trees close to the center to be a bit smaller. We saw earlier that we can have attributes, metadata, on our point and do operation on it. With the Spline sampler, we already have the density that is encoding the distance from the center. The bigger the density is, the farther away I am from the center. Unfortunately, we are introducing some noise to the density, so we are losing this information. So what we need to do is to save it somewhere. As before, we created a new attribute. This one, we're going to do attribute operation, and we want to store the density into another attribute that we'll call distance. So if I inspect the result of this operation, you can see that I have a new parameter that is exactly the same value as the distance. So we are basically copying the value density into our new attributes that we call distance. Then we can apply the density noise and we'll still have this value here, distance, that is saved. So just before spawning our trees, we wanted to make the tree a bit smaller. So we'll copy back the distance in density. So I'm just going to reuse attribute operation and do exactly the opposite. I want to copy distance into density. And on there, you can see that I have my density that is 1 there, that is not close to distance. And now the density is exactly the same value as distance. We do this because we need to remap on density. In 5.2, we can only remap the density, but we plan to add support for remap for all attributes in 5.3. So here I want to remap my density between 0 and 1 to 0.5 and 1. And if I inspect the node, you can see that the density is now between 0.5 and 1. The points that are on the edge of the spline will have a density of 1. So if I debug, we can see that the points that are close to the center will have a small density, but not 0. And we do this because we're going to use this value to rescale. To use these values for scaling, we can do a math operation. And I want to apply the operation on the same set of points. The input are the same for both of them, but the input source is different. So I want to modify the scaling. So I will do scale. You can also find it there, scale. And I want to use the density in operation. And I want to multiply the value of the scale by the value of the density. And I want to write it back into our scale. So you'll note that the scale is a vector and the density is a float. We support some broadcasting operation like this for convenience. So in that case, we will create a temporary density vector with all its components set to density value, and then multiply each component with the scale component. So you can see that the scale was 1.1 and now it's 0.6, so it's smaller. So I remove all the debug info and I will plug back into our trees and then enable it. And now it's clearer. You can see that the trees are getting smaller and smaller the further we go to the center, and the trees on the edge blend nicely with the previous rule. That's a cozy clearing. So let's add a cabin. So I have this cabin. I will put the link into the description that I took from Sketchfab, from Padmadev Designs. So I already have an actor where I put the static mesh with the cabin and scale it a bit. So now I will just put it there. I think I'm just going to scale it back a bit like this and do a rotation like this. Perhaps put it a bit more in the center. There we go. So if we want to spot anything here in the clearing, we'll need to exclude the cabin. So I will add a tag on the cabin that we call cabin. So we're missing something though. We don't have any foliage anymore because we removed it. So let's fix it. So I go back into my graph and I want to reuse the interior of my spline sampler. And we wanted to set it to the same bounds that we had in our graph sampler. So we're just going to do a set node and then put -5, and -10, 5, 5, 10. And we'll do the same thing for the trees. That we're going to take the density node and density filter, just duplicate it, then we just plug it. We'll put a bigger noise max to have more foliage into the clearing. We'll still use 0.12 for the lower bound in our density filter. And of course, we don't want to spawn any foliage into our cabin, so we're just going to make sure that we are not doing that. So I will get actor data, same thing that we had in episode 3, all world actors by tag, and then we want the cabin. We only want a single point. If I debug it, we'll see that it is the big box, like this. And we still have the same issues with the steepness. So we're just going to duplicate the fixes that we had. So create a temporary attribute, that one, and then set it to the attribute operation. We add our points that have steepness of 0.5, and then now it's 1, which is exactly what we want. And then we do a difference, of course, always binary. We want to take our foliage and then remove our cabin. So you can see that I have like this little points there. And if I debug the difference, you can see that I don't have points that are colliding with the cabin. So now that we have our points cleared, we can just take the output of the difference and then plug it directly into the transform point for our grass. So it will spawn some foliage there. You could see that it is following a very, very strict grid. So I added some offset, like -20 and 20 on the offset, just to have it a bit more random. So if I remove the debug, you can see that I have now my clearing with some foliage. It's getting sparser. I get closer to the cabin. And of course, I can change the clearing. So if I move it like a bit this way, it will automatically change. Can move it. And that's it for this tutorial. So during this episode, we saw how to exclude spline from a generation with landscape spline and splines. We also had a glimpse of how to use attributes and metadata to add more logic in our world. And we finally created a clearing with interior sampling. This one was a bit denser than the others. That's because we had a lot of cover for splines, but there are still a lot of things to discover. I voluntarily stay high level in this rule for people to understand the basics, so you can combine all the knowledge and produce wonderful stuff. Some people already went out of their mind with some videos, so I put some of them in the comments since they are very, very nice. Next episode, we'll say something that is probably newer than mesh scattering. It's runtime generation. We'll see how to generate some runtime stuff and how to use variables controlled by blueprints to impact our PCG rule with attributes. Until then, have fun with the plugin. Take care.